terms of Great Lakes restoration, I'd like to introduce Professor Amy Marcarelli, and she's going to do this first section for us.
All right. So since 2010, Michigan Tech has been awarded 12 Great Lakes Restoration Initiative GLRI funded projects, and with one award pending in the 2012 fiscal year competition. And these grants, research projects have been led by scientists here at the Great Lakes Research Center at Michigan Tech, and also at the Michigan Tech Research Institute, which is a center of Michigan Tech that's based in Ann Arbor, so the work has been based in both places. And I'm going to organize, rather than talk to you about each project, I'm going to organize around these central outcomes, which are related to some of the main outcomes in the action plan for the GLRI. And I want to start with prediction of environmental threats for planning and management. One of perhaps the most visible funded efforts led out of Michigan Tech Research Institute is the harmful algal bloom mapping program in the Great Lakes. It started in 2011. This program generates annual extent threats to assess whether harmful algal blooms or HABs are getting better or worse. They produce these annual predictions that are provided to EPA and NOAA that are used for congressional reporting and planning for HAB severity. And also produce these weekly maps of the extent of algal blooms and water quality and public health concerns that are used by water intake managers, local stakeholders, ecologists, and biologists to understand what to expect in that window. And these are published weekly online at a website that is widely advertised and given people access and use. And these maps are also being used to plan basin-wide management efforts. So this is work being led by Dr. Marty Auer here at the Great Lakes Research Center, focused on how we might control this emerging threat across all of the Great Lakes and along Michigan shorelines. This idea of linking mapping to on-the-ground management is something that's a theme that runs through all of our GLRI-funded projects. A lot of the projects I've been involved in have been based around invasive species control. Since 2014, we've been working on control of Eurasian water milfoil, which is a non-native plant that can grow and form these dense surface canopies that are an impediment for fish and fishermen. It detracts from local property values, is a real deterrent for boating and recreation. Many of the local communities are really concerned about Eurasian water milfoil because of its threat on tourism income. Here on the Keweenaw waterway and other places in the upper Great Lakes, Eurasian water milfoil has really just started to become a threat in the last 5 to 10 years. And part of what we're trying to understand is why is it emerging now as a threat? And how can we improve control measures? One of the things that we're seeing locally is that some of the more traditional herbicide methods don't work that well in these northern Great Lakes, and we're trying to understand why. Another key for controlling Eurasian water milfoil in this area is early detection. So we're working with hydrodynamic models to understand how fragments of the plant may spread, with different technology for detection of Eurasian water milfoil, like side-scan sonar, like on some of the instrumentation out here in the lobby. And also remote sensing, aerial remote sensing, to try to map Eurasian water milfoil likely back to Cladophora. And this work is ongoing in the Relational Islands, where we're working with the local community there that's testing the use of an indigenous fungus as a biocontrol for Eurasian water milfoil, and then developing these remote sensing tools that we can implement on drones, like this hexacopter here, to fly over large areas and monitor the effectiveness of different treatment.